Hey there, Math Hoppers. Today we're going to do a lesson on interval notation, which really isn't a lesson all by itself, but it's involved with so many other things and it tends to trip people up. So we're going to clear it all up today. So remember when we dealt with intervals on a number line. So for example, solving compound inequalities, and we would represent the solution where x was greater than or equal to -3 but less than or equal to 1. This solution represented that interval from -3 to 1 inclusive. And it was inclusive because both -3 and 1 were included in the solution. Both -3 and 1 satisfied the inequality. On a graph, remember we had to solve and graph, we would graph it with closed circles. And the closed circles meant that -3 and 1 were also part of the solution. So today, interval notation deals with expressing this but without a number line. So when we say without a number line, we're going to express the interval from -3 to 1 inclusive in a few ways. The first way is with grouping symbols, and this is what is traditionally known as interval notation. So grouping symbols for this instance would be a hard bracket, -3, comma, 1 hard bracket. Very important that you notice the hard brackets. Hard brackets represent the fact that -3 and 1 are included in the solution, and we call this a closed interval. We can also use set notation. Now, set notation uses some really funky mathematical symbols and it uses inequalities. So let's look at it and not freak out. Okay, so right here, this right here means x is a member of the set of real numbers such that it follows this rule. And the rule is that x is greater than or equal to -3 but less than or equal to 1. So this same inequality that we saw on the previous screen is included in set notation, just with this funky math knowledge or math symbolism that means x is a member of that set of real numbers that follows this condition. All right? You'll see interval notation more than you see set notation, but in case you see set notation, don't let it freak you out. Okay, now we said -3 and 1 were included. What if they are not included? Is there a way to express them? Well, sure. We expressed that interval like this, and it was read, generally speaking, x is in between -3 and 1. And you could just say in between -3 and 1 because -3 and 1 weren't included. And when we graph them, remember that we would use open circles for both -3 and 1 in that case. So we can express this with interval notation as well. Notice the brackets though. I am not using hard brackets. I have soft parenthesis, -3, comma, 1, close parenthesis. And that's important. The soft bracket or the parentheses represent the fact that -3 and 1 are not included in the solution. And this is known as an open interval. And of course, we can use set notation for this as well. Again, we have the funky math language that just says x is a member of the set of real numbers such that it follows this rule, right? X is a member of the set of real numbers, that's what that big funky capital R is, real numbers, such that it follows the rule where x is in between -3 and 1. All right, let's change this up a little bit. What if only -3 is included? Okay, well, if only -3 were included, then remember we would include the greater than or equal to -3, but just the less than 1 when we used inequalities. So guess what? We could do this with interval notation as well. We are only going to use the hard bracket right around -3 because the hard bracket says -3 is included. The soft bracket says 1 is not. Again, we can use set notation. Remember, set notation just has this weird math symbolism. X is a member of the set of real numbers such that it follows the rule where x is greater than or equal to -3 but less than 1. Okay, so anything we can represent with interval notation, we can use set notation to represent. Okay, how about if everything is greater than -3? With an inequality, this was really easy. We just said x is greater than everything -3, right? We said x is greater than -3. That was really easy. Okay, well, in interval notation, we again say soft bracket -3, comma, infinity, because everything greater than -3 goes to infinity. Now be careful. With infinity, it always gets a soft bracket. -3 gets a soft bracket because it's not included. There's not or equal to -3. But infinity always gets a soft bracket because it's not a number, it's not a value, you can't include it. Set notation looks like this. X is a member of the set of real numbers such that it is greater than -3. Very easy. If you can do the inequality and you can remember this math symbolism, you can do set notation. Well, we did greater than 3. Let's do less than -3. So what if the interval is everything less than -3? Then we simply wrote x is less than -3. And as you might imagine, we can do it in set notation, but what we have to do this time, if everything is less than -3 is included, we are going not to infinity, but we are coming from -infinity. So we go from -infinity to -3, not inclusive, so soft brackets on both. Remember, infinity and -infinity can never have a hard bracket. They're never included. And we can use set notation as well. Simply say x is a member of the set of real numbers such that it is less than -3. Okay, so now you're thinking, when are we really ever going to use this? Because like I said in the beginning, this isn't its own lesson. It just comes up a lot. It doesn't only come up solving inequalities though. It comes up because it's just a way to represent a range of values without using inequalities. So anytime a range of values is asked for or given, you could use or see interval notation. So the most common example is to describe the domain or range of a function. Suppose they give you this graph. It's a square root function. You don't even need to know that. But let's say they asked you for the domain or the range. You would say, okay, the domain is the set of all x values. Here's x. It looks like I start at 1 and I go on forever. My range, that's my output values, my y values, looks like they start at 2 and go on forever, just slowly. And so we would simply say the domain is the set from 1 inclusive to infinity, and the range is the set from 2 inclusive to infinity. Notice soft brackets on infinity, it can't be included. Okay, another important thing to note, when you do this, the smaller number is always on the left. The smaller value is always on the left of your interval. All right, I hope this was an easy lesson. I hope it helped clear up some things that you've maybe seen that were confusing. If not, send us your questions. You should be subscribed to our YouTube channel. Go ahead and take a picture of your problems that are giving you grief. Send them to us and we will make a video solution. Until next time, Math Hoppers, take it easy.